little bit of whiteboard practice, and I was pretty pleased with how we ended up. It seemed like everybody was on top of things, so that was good. But we're going to talk specifically about a piecewise function that has a special name. So above this, write step function. If you ever see a function that looks like this, with like double brackets, for some textbooks, they use this notation to tell you it's this type of piecewise function. So I'm just going to show you what it looks like. We're going to write it as a piecewise instead of with these brackets because this is more a common way, but I do want to show you that at least to, I don't know, in case it pops up. But this means the same thing that we're going to be doing now. Write down 4, 6, and -2. And then our domains here are going to be if x is between -2 and 0. Okay. And then the equation is going to be 6 if x is between 0 and 3. And then it's going to be -2 if it's between 3 and 7. Give you a second to write all that down. All right. Now, when we go to graph this, like all the ones that I've had you do yesterday and the ones in your notes look more like this, where you have some normal lines with some y-intercepts and slopes, and then we have some horizontal lines. But in this case, for example 4, what are all 3 of those lines? They're all horizontal. You don't have any slope for any one of them because technically we could write that as 0x plus 4. All you have is the y-intercept. You don't have a slope value there. So we're going to start with graphing horizontal lines. Now, I'm going to do this without graphing the whole entire line and then cutting it off like we've done before. I'm just going to know where the line is and then determine the cutoff points and just draw the little piece where it should be. So this horizontal line of 4 would go 1, 2, 3, 4 right there. What are my 2 cutoff points? -2 and 0. Okay. So I'm going to go to where x is -2. 1, 2, 3, 4. And is there going to be a solid dot or an open circle there? There's going to be a solid dot there. And then where x is 0, 1, 2, 3, 4, is that going to be a solid or open? That one should be open, I think, because there's no equal to bar. Should be open there. And then when you have a domain that's written like that, you want to keep the part of the line that's between -2 and 0. So we're going to keep the middle part here. So especially these step functions, don't feel like you have to draw the whole line and then cut them off and erase. I mean, you can just go and draw the little piece that you know should be there. Okay, and then we're going to go to the next horizontal line at 6. This one's cutoff points are 0 and 3. So I go to where x is 0. 1, 2, 3, 4, 5, 6. And should I put a solid dot or open circle there? That one should be a solid dot because you have an equal to bar. And then at 3, we should have a open. Okay, and then again, because it's this domain, it's asking for x values between 0 and 3, so we're going to draw another little. Are you catching on to the fact why this is called a step function? It's going to kind of look like stair steps. They're all flat portions that you draw. All right, and then -2 is between 3 and 7. All right, let me rephrase. The horizontal line is going to exist between 3 and 7. So we go to where x is 3, go down to -2. That one's going to be a solid dot. And then 4, 5, 6, 7. You have an open circle. So you take a few steps forward and then fall off the stairs and land on the floor. I don't know. But this would be a step function. The reason it's called a step function is because you have all horizontal lines. And it does model stuff like shipping costs, where if your package is between I don't know, 0 and 50 pounds, you're charged $8 to send it. And then if it's between 50 and 100, they charge you $10. So between a certain range of values, you're charged one thing. It doesn't fluctuate based on weight or something, or size. So these do apply in several different scenarios. A lot of times with sales, because they give like ranges that a certain price is going to be, and then when it gets bigger or it weighs more, it bumps up a bracket. All right. Oh, what's another? Well, you guys might not know this yet, but there's something that affects everybody in America and pretty much in the world, where we could graph a function that looks like this. Has something to do with the month of April. Taxes. There's something called tax brackets, and if you make between like 0 and I don't know what the tax brackets are, but between 0 and let's say 25,000, you're one tax bracket, so you have to pay a certain percentage of your income. And if you make 25,000 to I don't know 60,000, you're in another tax bracket. So that could be modeled by a step function like this. All right, for example 5. This would be an example of a 4-type problem. And also example 6 would be an example of a 4-type problem. Give me a second here. Well, let's actually use a graph that's already drawn. Let's do 23. Okay, so for this example, we're going to use this graph. And what you have to do for the piecewise functions to get a 4 is you not only have to graph it, the graphing part on your own is the 3. So if you can do example 2, 3, and 4, you're golden on that. To bump it up to a 4, you have to be able to look at a graph like this and write an equation. Okay, so you have to like do the backwards part of it. So what I would suggest is when you're given a graph, you start with one chunk at a time. So I'm going to start with this chunk here. And I need to write an equation of a line that models that piece. So we start with what we know, which is y equals mx plus b. Hopefully I can find my y-intercept, and hopefully I can find my slope. What is the y-intercept of that little chunk there? 2. I can see that it crosses the y-axis. What if it crossed at a really random point and you weren't sure? Could I just pull off 2 different points on the line to find the slope and then the y-intercept? Yeah. If you don't have a nice grid point that you're crossing on, you can just pick 2 points and then do what you've done before, stack and subtract, and write the equation on the line. But in this case, since it actually crosses the y-axis, we're going to say, okay, my y-intercept is 2. And then how do I find my slope? We can stack and subtract, but if it ends on nice grid points like this, you just count boxes. You find rise over run. So to get, let's say, from this point here, which is a nice grid point, to this point here, which is a nice grid point, I have to go which direction? I have to go negative 2 and then over 1. Okay, so your slope would be negative 2 over 1. And then the y-intercept was 2, right? Okay, so we're going to go ahead and start with that one. Now, just so that you have something to work off of here, I would draw a rough sketch of that. So put a y-intercept. Oh, because I'm zoomed in really, really far. Okay. Check it out again. Just so that you have something to work off from your notes, I would make sure that you identify, or like, we're going to basically copy that graph down. So at the x value 1, we had an open circle, then we had a y-intercept of 2, and then we just draw a line. Alright, now based on this graph that we have, because we only have the one piece drawn in, I have to give this chunk a cutoff point. What's going to be the cutoff point for this line? The x value is 1. Good. So I would write that as a little domain statement, that this piece of the line exists if x is what to 1? Well, is the line to the left or to the right of 1? It's the left, so it would be less than. Oh, and it's just less than actually, right? Because we have an open circle there. Yeah, so it should be x less than 1. Okay, so you come up with the equation of the line either by finding 2 points and stacking and subtracting and doing it that way, or if it crosses at a nice grid point, that's nice because then it does some of the work for you. All right, let's go ahead and look at that graph again to look at the next piece. Okay, now I cheated here, and this line stops there and goes to the right, but I said, well, instead of finding 2 points and stacking and subtracting, let's try to extend that line out just to see where it would cross the y-axis if the whole thing was drawn in. Because if I can find the y-intercept, it just cuts down my work a little bit. So if I extended it out, which I can see that the slope, well, let's start with the slope. What's the slope of this line? 1, right? Because this is a nice grid point, this is a nice grid point. To get from one to the other, I go up 1 over 1. So I just went down 1 to the left 1 and hoped that it crossed a nice grid point on the y-axis, which it does here. So for this line, the slope is 1, but what's the y-intercept? -3, right? So we can write that equation line without having to stack and subtract 2 points. So we have x minus 3. And you might want to graph that in to just, again, to have, oops, again, you can't see. Excuse me, just to have a nice little spot there. And then we have to give it its domain. What's the cutoff point for this line? Still 1. Remember that wherever the first one leaves off, the other one has to pick up. So this domain is going to be written as if x is what?
Greater than or equal to.
Good. Greater than or equal to 1. Okay. You're going to get more practice on that today, about 3 more looks at that type of problem. A different kind. But at least 1 for your notes when we talk about it. And then for example 6, I meant to type in the example here, but we're just going to go ahead and write it. Okay. If Barrett, well, let me give you an example, or tell you why I chose name Barrett. Yesterday, my friend Jessica, she's pregnant with her 3rd, and she has like 3 little boys, and they're just so cute. Anyway, so they're trying to pick a name, and so I've been trying to convince her to use Ambero, because my name's Amber, and so I want one of her kids named after me, but it's a boy. And she texted me yesterday, and she said that she wants to name Barrett so she can call him Bear. I like Bear Grylls, and I'm like, yeah, I like Bear Grylls. So Barrett, and so now she's working on her husband to try to figure out if they can name their kid Bear. He refused to just name him Bear, so then she's trying to find different ways to still get the name Bear. Barrett, but I've never heard the name Barrett except his last name.
There's Barrett Jackson and other options.
Oh, so there are people in there. Good. All right. So if Barrett earns a commission of 5% on sales up to 50,000 and 8% on sales, well, I should say from 50,000 up, write a function that represents the situation. And then after we actually write the function that represents the situation, we're going to go ahead and use it to determine how much commission he actually gets. Can someone tell me what commission means? Because that's kind of important to know for this. If you make commission on something. sales, how many of you have watched The Office? Okay, so like Jim Halpert is a salesperson on The Office, and he would work on commission, meaning based on how much paper he sold, that's his salary. So if he sold no paper, he makes no money. Okay, so when you work on commission, it's usually a sales type position, or basically you're working for a company that if you don't do your job, you don't make money, because the company won't make money if you don't do your job. Teachers don't work on commission, but they should. If Barrett earns a commission of 5% on sales up to $50,000 and 8% on sales of $50,000 up, we're supposed to write an equation that represents this. We're going to start with the easy part by making f of x, and then I know this is a piecewise. How do I know this is a piecewise function? It says up to 50,000. It says from 50,000 up. But how many different things do I have going on here? I have two, right? Because I have two commissions and based on two different price ranges. But it's all talking about Barrett's commission, so it's two things that represent the same situation. Now, when you find 5% of something, like if I wanted to find 5% of 20, that means I'd have to multiply 20 by what? Do we know? Let's start with, I guess, maybe an easier. What's 5% of 100? 5, right? Yes? Do we not know percentages? Okay, so let's back up a little bit. Might be a little rusty. To find percentages of something, you take, let's say 5%. If I want to find 5% of 20, you take 20 and multiply it by 0.05. Because 5% means 5 out of 100%. So we have to convert it to a decimal in order to multiply it. And you would get 1 is 5% of 20. Okay. If you had, I don't know, 500 and wanted to find 5% of that, you'd get $25. So let's say he sold, just so we kind of get an idea of what percentage means. Let's say he sold 45,000. What kind of percentage would he be getting? 5% or 8%? 5%. So we'd multiply 45,000 by 0.05. He'd be making not a lot of money. Okay? But this hopefully is a big enough company where he's going to be selling millions of dollars of product a year. A lot of car salespeople sell millions of dollars of product every year. Their salary isn't millions of dollars because 5% is not actually a big percentage. But hopefully he's, I don't know, working for that kind of company. So at least, that's not a shabby 2-week salary. And in certain companies, selling in a car company, like it's easy to sell $45,000 worth of car, because selling 2 or 3 cars will probably get you to that. All right. So we have to basically know what he sold in order to find his commission, right? You can't just have the 0.05 be there and not multiply it by something. The 5% only means something if you have something to multiply it by. We do not know how much that he sold. So because you don't know how much he sold, that becomes your variable. And so the first function here is going to look like 0.05 times x, where x would be how much he actually sold. And so let's go ahead and label our variables over here. X is going to be amount sold, and y, or this f of x situation, is going to be his salary, or his commission. Based on how much he sold, that's how much he makes. Now, we would have an initial amount here if he had like a base salary. A lot of waitresses, or if you ever waitress or waiter in a restaurant, you're given a base salary of like $2 something, like $2.50. So every hour you're making $2.50, and then the over and beyond that is commission. And what's that commission called? Tip. Okay. So usually you don't make $2.50 an hour, you make more than that, but the rest of it's based on tips. So if we had some kind of base salary here, like let's say he made $250 a week, then that would be our initial amount. So we would add $2.50. But in this case, we don't have any base salary, we just have commission. So our function to find out how much he makes is just that 0.05 times x. Now we have to give this a cutoff point. What's the cutoff point for this? 50,000. He makes 5% up to 50,000. It actually has another cutoff point. What's the other cutoff point? What? 0, because you can't make money. I mean, you can't sell negative product or whatever you're selling. So this is going to exist for sales up to 50,000. And then the next piece of this function is going to look very much the same, except what changes? The percent. So it's going to change from 0.05 to 0.08. He makes a little bit more if he sells more. That's why sales people have to be really pushy sometimes. It's because their salary depends on it. And that cutoff point is what? 50,000. Does it have another cutoff point? No, it just says from 50,000 up. So it doesn't matter if he sells $1 million of product. He only gets at most 8% of that. So to write that, we would say if x is greater than 50,000, and then all of our little x values are covered at that point. Okay. So you'll get more practice. I don't know if you're getting practice on this type of for problem today, but you will get practice on that. You're getting more practice on this today because it's the lead-in. Any questions on any three of these before we start doing something else? Okay, thanks for your attention and your patience. All right, go ahead and look at your partner sheets.